Imagine for a second an AI that could actually do the job of a top-tier data scientist. I mean, not just writing some code, but solving really complex machine learning problems totally from scratch. It's the big dream, right? But so far, these AI agents have had this major problem that's been holding them back. Well, today, we're going to look at a new approach that might have finally cracked the code. So here's the game plan. First, we're going to pinpoint the exact blind spot that's tripping up current AIs. Then we'll meet MLE-STAR, the agent built to fix it. We'll get into its two superpowers, search and refinement, look at some frankly jaw-dropping results, and then talk about what this all means for the future of automation. All right, let's just dive right in. The whole promise of an AI data scientist is massive, but the reality? It's been a little bit flawed. They've all got this one critical blind spot. And it really just boils down to two big things. First, their knowledge is totally outdated. Think of a brilliant chef who's forced to only use a cookbook from, 2015. Sure, they're skilled, but they're missing all the new modern techniques. And second, their revisions are so clumsy. When that same chef realizes they use salt instead of sugar, instead of just fixing that one little thing, they throw the entire dish in the trash and start all over. It's just wildly inefficient. Okay, so this is where our hero enters the scene. A team of researchers from Google and KAIST developed a brand new agent to tackle these exact problems, and they call it MLE-STAR. And the real secret sauce? It's right there in the name. S-T-A-R. It stands for Search and Targeted Refinement. These two things are its superpowers, and they are designed specifically to fix those two huge problems we just talked about: outdated knowledge and clumsy revisions. So let's talk about that first superpower, search. Instead of just relying on some static internal memory bank, MLE-STAR kicks off every project just like a modern researcher would. It hits the internet. And this is where the genius really is, in this brilliant four-step starting process. First, it uses Google to find several of the latest and greatest models for whatever task it's been given. Then, it whips up a simple script for each one. After that, it actually tests them all to see which one performs the best. And here's the killer move. It intelligently merges the winners into one super powerful starting solution. It doesn't just make one guess. It starts from a position of incredible strength, built from the best of what's out there on the web right now. You see, this is a massive conceptual leap. We're moving away from an AI that just remembers old facts to one that is actively learning and adapting by plugging into the live, constantly evolving knowledge of the entire internet. Now for its second superpower. Once it has that really strong initial code, MLE-STAR has to make it even better. But instead of just scrapping it and starting over, it uses surgical precision. It does this with something called an ablation study. Yeah, it sounds super technical, but the idea is actually pretty simple. It's like our chef tasting their sauce, and then taking out the garlic for a second and tasting it again. If the flavor just completely tanks, they know that garlic is a critical ingredient. Well, MLE-STAR does the exact same thing with its code. It tweaks one little block at a time to figure out which parts have the biggest impact. And this all leads to this awesome targeted refinement loop. First, it uses that ablation study to target the single most important block of code. Then, it actually brainstorms a few different ways to improve only that piece. It tries them all out, picks the winner, swaps in the new code, and then it does the whole thing all over again. It's this relentless, focused, and incredibly smart cycle of improvement. And what's even better, it has these built-in sanity checks. A classic rookie mistake for AIs is something called data leakage, basically peeking at the answers during the test, which completely invalidates the results. Well, MLE-STAR has a dedicated checker that spots this error and just automatically rewrites the code the right way, just like a seasoned expert would. So the theory is fantastic, right? A web-searching, surgically precise AI coder. It sounds amazing, but does it actually work in the real world? Well, the researchers put it to the ultimate test: Kaggle competitions. 63.6%. Just let that sink in. That's the percentage of tough Kaggle competitions where MLE-STAR's solution was good enough to win a medal. That puts it right up there with top human competitors. But that number is even more incredible when you see how it stacks up against the previous best in class, an agent called AID. Look at this. MLE-STAR won a medal in almost 64% of competitions. That's more than doubling AID's 26%. And for gold medals, it won 3 times as often. This isn't just an improvement, folks, it's a blowout. I mean, this chart just says it all. You can literally see the massive gap. It's clear that MLE-STAR is just operating on a completely different level than anything that's come before it.
So this is way more than just a neat tool for winning some coding competitions. This is pointing to a fundamental shift in what AI agents are even capable of doing.
And honestly, it gets even crazier. MLE-STAR can run multiple independent sessions at the same time, creating several different, really high-performing solutions. Then, and this is the amazing part, it actually strategizes on the best way to combine its own creations into a final ensemble that's often better than any of the individual parts. It's not just a coder anymore, it's becoming its own team lead, figuring out how to make its own best work even better. So what this all really marks is a fundamental shift. We've gone from AI coders that just rely on a static internal memory to AI assistants that are true expert researchers, constantly learning and applying the absolute cutting edge. And that leaves us with this incredible question to think about. What new frontiers in science, in medicine, in technology, what problems can we finally solve when our AI partners can learn and innovate right alongside us?